Good evening, students. Yesterday we have discussed about the Coulombs law. That is, if the two charges are there, then there occurs a force between the charges, and the force between the charges depend upon the product of the charges and inversely proportional to the square of distance between them. So that relation we have discussed, where force was K, Q1, Q2 upon R square. What was K? K is 1 by 4 pi epsilon naught, and its value comes out to be 9 into 10 raised to the 9 SI units. So where epsilon naught is permittivity in the free space. So that we have discussed last time. So then we have find out there was a relation between E and E naught, which is equal to ER. That is when the forces has to find in some other medium. So that E is the permittivity in medium and E naught is the permittivity in free space, that is called to ER or K, which is called as the dielectric constant. So that part we have discussed last time. So that made that the force in medium comes out to be force in air divided by 1 by K. So that means if the two charges are placed in a medium and then they are taken to certain some certain medium, first of all they are taken air and then they are taken to certain medium, then the force in that medium will be equal to 1 by K times the force in the air. So that relation we have discussed yesterday. So today's topic we will discuss about the Coulomb's law in vector form. How in vector form we are going to take this law. So vector form means it has magnitude as well as direction. So how the magnitude and direction are going to be takes place. So consider two charges at point A and B. So let us see. Consider two charges Q1 and Q2 at point A and B, which are at distance R1 and R2. So these are the two different charges are being taken. Now let F12 is the force on 1 due to 2, force on 1 due to 2, and F21 is force on 2 due to 1. So that is a different forces which are being acting. Since they are same charges, so they are the forces are acting in the opposite direction. So one is exerting force in this if the other is exerting force on this, because we know like charges repel each other. Now let us say AB. AB is calculated as B minus A. B minus A means R2 minus R1. If you take BA, BA will be taken as A minus B, that is R1 minus R2. So basically this is the way how we can take the value of AB and BA. Now F21 we have seen force of 1 on 2, that is force by the charge particle 1 on 2, that can be calculated by formula K or 1 by 4 pi epsilon naught Q1 Q2 upon what is the distance, that is equal to A to B. A to B means AB. AB is, what is that? What is the value of AB? Is R12. So R12 whole square. And if you have to point out, since we are taking about the vector form, so we have to point some direction. So that is taken as R12 cap. So R12 cap is basically equal to R12 vector upon R12. So we can write this as R12 vector upon R12 cube. So that is in vector form we can write this as a F21 is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R12 cube into R12 vector. Now we calculate the other way, F12 which will be equal to this one. Now the force will be equal to B21 because force on 1 due to 2. So that will be taken as R21. So that R21 whole square will be taken, and then the unit vector is being taken, and then we have made the value of the force to be calculated out. Again unit vector R2 is equal to R2 vector upon R21. Now since we have seen here AB is equal to R2 minus R1, VA is equal to R1 minus R2. What is the correlation between them? There is a negative sign, because if you take a negative common, it will become R2 minus R1. So that means AB is equal to minus of BA. That means R21 is equal to minus of R12. So if you put it here, rest of the things are same, because here it is a magnitude only and here it is a direction. So they will be opposite to each other. So that shows F21 is equal to minus F12. So that means forces are equal and opposite to each other, so which obeys the Newton third law. So which state that two forces which are being exerted by 1 on 2 or 2 on 1, they opposite to each other, and that obeys the Newton third law. Let two charges of 1 nanocoulomb each are placed in air, exert a force of 10 Newton, and distance between them is 3 meter. If the distance remains same, they are placed in a medium whose dielectric constant is 5. Find the force between them. So that is a very good question. So we know that force in medium is equal to F naught upon K. Now it is given that force in our this one air is equal to 10 Newton, dielectric constant is 5, that is equal to 2 Newton. So that means force in medium will be reduced 1/5 times the force in the air. So that was the first question. Next problem is force of attraction between two charges placed at D is F. Placed at D is F. What distance should they be kept so that force between them is 2F? So that we have to find it out. So again we read the question. First of all, the force of attraction between the two bodies and they are placed at a distance d apart is F. Yeah, it means we are given F is equal to K Q1 Q2 upon D square. So that the force is F. Now if the charges are placed at r distance apart, then the force become 2F. Now the new force is F dash K Q1 Q2 upon r square. Now how to find out the relation? Now this force is become, what should be the charges, that the force between them is 2F. That means F dash is equal to 2F. So call this as equation 1, call this as equation 2. We have to find the relation. So that means F upon 2F is equal to 1 upon D square into R square upon 1. So what does it mean? F get cancelled, R square upon D square is equal to 1 by 2, which implies R by D is equal to 1 by root 2, or R is equal to D by root 2. So that means the distance will be changed by this factor if the forces are being there. So such kind of questions we are going to discuss more in details in the next lectures, and that will be very very important questions which will be based upon the NCERT book, and then we will give you some exercise to practice these questions. So such kind of questions will be generally asked into the paper. Thank you.